Hello everyone. Today we are going to learn the concept of error. We know that the purpose of quantitative analysis is to accurately get the content of the components in the sample. In actual determination, due to the limitation of analytical methods, instruments, reagents, and operation techniques, the result of measurement cannot be exactly the same as the true value. Error is an objective existence. In the course of experiment, we must understand the causes and rules of the error, so as to take actions to improve the accuracy of analysis results. At the same time, the accuracy of analysis results should be correctly expressed and evaluated. Let's learn the first set of concepts: accuracy and error. Accuracy is the closeness of the measured results to the true value, and is expressed by the term of error. It shows the reliability of the measurement results. The smaller the error, the higher the accuracy of the analysis results. Errors can be expressed as absolute error or relative error. However, the absolute error cannot fully tell the accuracy of the measurement, because it is not associated with the quantity of the tested substances. If the mass of the weighing material is 1 gram and 0.1 gram respectively, both the absolute error of the weighing is 0.0001 gram, then its meaning is different. So the accuracy of the analysis result is usually expressed as relative error. The relative error equals absolute error divided by the true value and multiplied by 100%. The relative error reflects the percentage of error as to the true value in the results, which is used to compare accuracy of the measurement results and various circumstances. Precision and deviation. Precision indicates the closeness of parallel measurement results and is expressed by the term of deviation. The absolute deviation is equal to the measured value minus the average. Therefore, the absolute deviation can be positive and negative, and it may also be zero. The mean deviation is the sum of absolute deviations divided by the number of measured times. The relative mean deviation is the ratio of mean deviation to the average. The average deviation is relatively simple, but the shortage is that in a series of measurements, the number of small deviations is always the majority, while the measurement of large deviations is always a minority. Therefore, in mathematical statistics, standard deviations are usually used to express precision. The expression is as follows. In the formula, n-1 is a degree of freedom, which shows that there are only n-1 variable deviations in the n test. It can be seen that the standard deviation strengthens the function of large deviation data, so it is more sensitive to the precision of the measured value than the average deviation. The relative standard deviation, also known as the coefficient of variation, is expressed by CV, which is equal to the standard deviation divided by the average and multiplied by 100%. A large number of experiments show that accuracy is related to precision. Generally, the high precision of the measured value indicates the stable determination condition, which is a prerequisite for high accuracy. However, due to possible error factors, high precision doesn't necessarily mean high accuracy. For example, 4 people A, B, C, D determine the copper content in a certain ore sample simultaneously, and their results are listed in the table. The precision and accuracy of A's determination are good, and the result is reliable. The result of B is accurate, but the difference between the mean and the true value is great, so accuracy is low. The precision of the determination of C is not good, as well as the accuracy. The average value of D is close to the true value, but the precision of the measurement is very poor, taken as a coincidence. Therefore, good precision is the premise of good accuracy. Good precision doesn't necessarily mean high accuracy. High accuracy must be armed with good precision. Precision is a prerequisite for ensuring accuracy, and high precision can lead to high accuracy. The error is divided into 2 categories: systematic error and random error, according to their causes and properties. Systematic error is a kind of error caused by some fixed reasons in the analytical process. It has the characteristics of repeatability, unidirectionality, measurability, and so on. That is, under the same conditions, it will occur repeatedly in repeated determination, making the result systematically high or low, and its value also shows certain rule. According to the sources of systematic errors, it can be classified into 4 categories. 1. Method error. It arises from the imperfect analysis method itself. For example, the reaction is not completed quantitatively with set reactions. The endpoint error caused by the inconsistency between the titration endpoint and the stoichiometric point, and the existence of interference components. 2. Instrumental error. Mainly due to the inaccurate instrument or using without calibration. For example, use the electrolytic balance without calibration, and containers or meters of titration analysis are not accurate or calibrated. 3. Reagent error. Coming from the impurity of reagent or trace impurities in distilled water. 4. Operation error. Mainly referring to the errors caused by incorrect operation of analysis. For example, the reading of burette is always high or low, the usage of samples, lack of representative, and so on. Systematic error, also known as measurable error, can be corrected by means of control test, blank test, instrument calibration, and so on. Random error is also called accidental error. It's kind of error caused by some uncontrollable, unavoidable accidental factors. It has uncertainty of value and fluctuation, also known as indeterminate error. For example, the slight fluctuations of temperature, humidity, and air pressure during the measurement, the influence of dust, and so on. These factors are difficult to be detected or controlled, and not possible to be avoided. The random error is the combined effect of these contingencies, and its value determines the precision of the analysis results. Although the random error cannot be reduced or eliminated through calibration, its distribution obeys the statistical law and can be reduced by increasing the number of parallel measurements. Besides, we should pay attention to the errors caused by carelessness or violation of operational requirements, leading to gross errors. For example, loss of samples, adding wrong reagent, reading wrong scale, recording errors, etc. Gross error is an important factor in causing serious errors in measurement, but in essence is only a kind of mistake and doesn't possess the nature or regularity of the above error. Only by strengthening the sense of responsibility, cultivating rigorous, meticulous working style, and strictly operating according to the operating rules can gross error be avoided. Well, today we learn the concept of error and understand the sources and the regularity of the error, as well as the effective actions to reduce it, thus improve the accuracy of the analysis results. Now, here is a question. The reading error of butyrate is 0.01 milliliter. If the used standard solution is 5 milliliter, what is relative error? If 25 milliliter standard solution is consumed, what is the relative error? What is the conclusion from the value of the relative error? Okay, that's all for today's study. See you next time.